All right, let's make this happen in one more video. Okay, so we're going to look at the next one. We are going to use the same base, but this time we're going to have rectangles of height 1/4, which are perpendicular to the y-axis. So what we're saying here is that instead of going in that purple direction like we have, our rectangles are now going to go this way. Okay, so we're going to set our rectangles on the function this way, so they're going to be a different height than they would be otherwise if we went the other way. So now we're setting them this way instead of this way. Okay, so let's just start setting up this integral and then do a little bit of more math. Okay, so what are our limits of integration going to be? What's the lowest y value that we're going to take, and what's the highest y value we're going to take? Because we're now integrating with respect to y because we're stacking them all up on the y. So our lowest y value is 0, and our highest y value is 2. And we're going to then integrate the area of the base, and our base is a rectangle with height of 1/4. And so the area of a rectangle is base times height. And then we're going to differentiate, or we're going to integrate with respect to y. So we're going to start with 0 to 2 of base times height dy. Well, we can't integrate that yet because it's not in terms of y. So what's the height? Well, we know the height is 1/4. Okay, so we're good there. 0 to 2 of 1/4. Now, since 1/4 is a constant, we're just going to take it out of the base dy. Okay, so now we just have to figure out what the base is. So we're going to look up here at this, and we're going to realize that the base is this, left minus right. The base is really this function right here. And so we want this in terms of y. Right now, we have it in terms of x. Right now, we have y equals negative 2x plus 2. And we want x by itself, and we want to know what that function is in terms of y. So let's just do that. We're going to do y minus 2 divided by negative 2 equals x. So our function in terms of y is y minus 2 over negative 2 equals x. So we're going to rewrite that. Our base equals negative 1/2 y plus 1. Make sure I got that right. Yep, negative 1/2 y plus 1. So it's negative 1/2 y plus 1 is our actual base. So everywhere that we had our base, we're just going to go ahead and replace that with the area of our base, or the value of our base that we just figured out. So there you go. That is set up. That would be, and then we would just evaluate that. So say we used a calculator or something like that, we would use one of those methods to evaluate that. All right, so we're going to set up an integral for the volume of a solid whose base is bounded by, that's a parabola, y equals negative x squared plus 2, and then that should be y equals x. It doesn't show up on our screen very well, but there it is. There's the equal sign. Okay, so first things first, we're going to go ahead and draw this. And so you're going to think way back to pre-calculus and earlier in the semester where we remember transformations, because that's going to help us quite a bit here. So the first one is a parabola facing down, shifted up 2. So our parabola is going to go 2, 4, 1, 2, 3, 4. So it's going to go kind of like this. Aha, there we go. Okay, so there's our parabola. And then the line y equals x, remember, just goes through the origin. It's a parent function. It's just a straight line. And so we're looking at the area that we're actually looking at that's going to be the base of our solid is going to be this area here in red. And then we're going to stack, it looks like we're going to stack squares on top of it, and they are perpendicular to the x-axis. So I should write I should draw these red ones better, so I'm going to do it like this. We're going to draw these. These are perpendicular to the x-axis. So again, just imagine this is a 2D shape that you're seeing. So just imagine that I lay my paper down, and then I just take some squares. I take a square, and I put the square on top of that red line, and I just do lots of them, okay? So we're going to set this integral up. So the first thing is we need to find our limits of integration. So we need to find what our lowest x value is and our highest x value. And so what is our lowest x value? Where do those actually cross? To find their intersection points, we can set them equal to each other. So we have right here where y is, I'm going to replace it because I know that y equals x. So everywhere there's a y, I can put x equals negative x squared plus 2. And then I'm going to go ahead and get that on the other side. So I have 0 equals negative x squared minus x plus 2. And I'm going to factor out that negative 1 because I hate factoring when a is greater or is not 1. Because you have to do like slide and divide, or there's all sorts of methods, rainbow, whatever. They're just complicated. So we factor the negative 1 out, and then we go ahead and factor this. And we get negative 1, x minus, or plus 2, and x minus 1 is going to give us that. So we know that these cross when x equals negative 2 and when x equals 1. So this point right here, x equals negative 2, and this point, x equals 1. And we know that it would be 1, 1, and negative 2, 2, because we know that y equals x in this case. So what are our limits of integration? I'm going to go ahead and erase all that mess. Our limits of integration are lowest x value to highest x value. So we're going to integrate from negative 2 to 1. And then we're going to have the area of our cross section. And so these are squares. These are squares. So the area of a square is side squared, and they're perpendicular to the x-axis, so that's dx. And then we have to decide what is our side. Okay, what does side equal? Well, the side equals this length right here. There it is. This length right here, right? This minus that. This minus that. This function minus that function. So the output of this function minus the output of that function, right? So to find the actual area of the side, we're going to do top minus bottom. Negative x squared plus 2. That plus sign didn't turn out very well. Negative x squared plus 2 minus the bottom function, which is negative x. So we're going to go ahead and we're going to just, that's what a side is, right? So we're going to plug that in here for the side, and that's negative x squared minus x plus 2 squared dx. So that is the setup for our integral. And again, we don't have to integrate it. So last one, we're going to set up the integrals for the volumes of the solid whose base is a circle. What? And cross sections are equilateral triangles perpendicular to the y-axis. All right, so first things first, we're going to draw this. So imagine that I'm setting an equilateral triangle onto this circle. So if you think about our thing right here, we have equilateral triangles. So you're setting equilateral triangles on top of, in this case, we're going to be setting them on top of a circle. So this is what we're doing here. Isn't that crazy looking? Like, okay, so if you can imagine, I know this is taking up all this time, but look at that. So there's our triangles, and they're set. There's our circle, and we set triangles on top of it, and we're trying to find the volume of that solid. Okay? So they're perpendicular to the y-axis, which means we're going to differentiate with respect to y. And so the first thing first is we've got to get our function in terms of y. So we got to get x by itself, so it's all in terms of y. So if we want to do that, we have x squared equals 1 minus y squared. And then we have to take the square root of both sides. And remember, when we take the square root, we get plus or minus, right? So basically, this is x equals plus or minus the square root of 1 minus y squared. So the plus is this side, and the minus is this side, okay? So, it's hard to picture, I know, but the plus root 1 plus minus y squared is the blue, and then the other one is the red. So the question is, what is the actual distance between the two, between those two? So what is the side length of our equilateral triangle? Well, it would be the right minus the left, okay? And the right is square root of 1 minus y squared, and the left minus the left, which is negative square root of 1 minus y squared, okay? So we did the right minus the left, which is really two of those, right? Because we're adding or subtracting a negative, so that makes 2. So then we have 1 minus y squared. So our side of our equilateral triangle is 2 times 1 minus y squared. Okay, so we have our side length. Now let's start setting up our integral. Our integral is going to be integral of the area of the base. So the area of an equilateral triangle is square root of 3 over 4 times the side squared. Am I getting that right? Yep, times side squared. And so we know that the side is 2 root 1 minus y squared. And so we square that. And then we have to decide what our limits of integration are. Well, what's the lowest x value, or excuse me, what's the lowest y value it takes? Well, it has a radius of 1, so it goes to negative 1, and it goes up to positive 1. So negative 1 to 1. And since the root 3 over 4 is a constant, we bring it outside the integral, and we have 2 over 1 minus y squared dy. Don't forget the dy, because that tells us that we're integrating with respect to y. So there we go. We set that one up. And then what if we were rectangles instead? So again, our volume equals the integral from, instead of setting equilateral triangles on top of our circle, we're now setting rectangles on top of our circle. So it's still from negative 1 to 1. And what is the area of a rectangle? Well, it's base times height, dy, because they're perpendicular to the y-axis. So they're still going on that red line. They're still going on this red line right here. They're just rectangles now instead of triangles. Okay, now what's our height? Rectangles whose heights are 3 times their bases. Okay, so we got to figure out what the base is. Well, the base, we already figured it out. It's the same as the side. It's that red line. So our base equals 2 times 1 minus y squared, the root of 1 minus y squared. So we know base, bring this up, our base is 2, 1 minus y squared, root 1 minus y squared, so that's our base. And what's our height? Well, it's 3 times that, right? Their height is 3 times the base, dy. So there we go. The area of the rectangle integrated from the lower limit to the upper limit, dy. And if we wanted to look at this, instead of equilateral triangles, we're now going to have rectangles on top. And that is the area, the volume that we are actually finding. So that's pretty awesome. So I hope you're sufficiently not confused, actually. I hope you're not too confused. I understand that this is a lot. So we will talk some more in class.